So good morning, everyone. So I'm Sonia Vanier. I'm a professor at École Polytechnique and Institut Polytechnique de Paris also in the computer science department. So I'm very, very happy and very honored to be with you today. I already was in the first edition of this conference on AI evolution. So I'm glad to see that we have a second edition of this conference. So we are consolidating this initiative, which is very, very important, especially in this place. So I totally agree with you, Juan Antonio and Christopher. Today, more than ever, it's crucial to build bridges and to create communications and collaborations between research academia, between the digital industry, European policy makers and European institutions around all the challenges which are created through the digital technologies, especially with AI. And yes, Brussels is the great and the important place to discuss this kind of challenges. So it's our responsibility for research and academia community to help our society in all this revolution which will be created thanks to the digital technologies, especially with AI. So for me, I'm really, really happy to chair the first session of this great conference dedicated to the artificial intelligence impact on society and on sustainability. So before starting and letting the floor to our five great speakers, I really would like to thank you, Juan Antonio, Maria, and all of your teams for your huge work and investment to make this event possible and to creating and providing us this opportunity to discuss on these big and great challenges because I agree with you, Christopher. It's a question of European sovereignty and European security, and all of us, we have a key role to play to help our European institutions to make the right decisions and to go together through the right direction, how to use the AI, especially technologies, for good things and how to prevent all the challenges and the risks which are provided with our new technologies. So today, I'm very happy to chair the first session, which is a full woman session. This is the first time on my whole career in computer science to chair a full woman session. So we'll have the pleasure to hear our five great speakers talking about her works. So I'm very happy to say her works. So starting from a general introduction to trustworthy and responsible AI. So it will be Natalia, and then we'll go through societal impact of AI, and then going on more applications of AI to energy using large language models and the multimodal AI. So Natalia, the floor is yours. I will just, I want to ask our speakers to talk here because the audience, the online audience will not hear you other way, and please keep the 10 minutes. Thank you very much, and I wish for all of you a great conference. Thank you.
Bonjour, jeune homme.
Can I put it on that one? Yeah.
Are you ready? Okay, so Natalia, the floor is yours.
Okay. Good morning, everyone. Thanks, the committee, for inviting me. I'm going to talk about Trustworthy AI for Axis Vision that we have recently published in this paper on from Trustworthy AI to Responsible AI Systems. And what it means to achieve it technically from what we are working on, especially on the topics of explainable AI and neurosymbolic and continual AI. As you know, I want to bring your attention that this is a topic that concerns all of us, even though it's regulation and we don't usually care so much about it as we are really focused on the technical details. I want to bring your attention that this is going to affect many fields of areas of development, especially we have, as you know, the regulation settles 4 levels of risk, and they are based on scenarios of risk AI applications. And we have from the base of the pyramid, the applications without risk or minimal risk, like for instance, video games or recommendation systems, industrial prognosis. Then on level 3, we have applications with limited risk, like emotion recognition, chatbots, deepfakes. On level 2, we have the ones that are highly regulated. We are going to see how this affects probably any side of your research. I think many people in this program, I saw that they will be actually affected by this regulation. And this is why I want to explicitly mention to all of you. And then the level 1 is applications with unacceptable risk. If you remember the chapter of Black Mirror where the person couldn't get on a plane because she didn't have enough points and she had a bad day and they didn't give her 5 stars. So these kind of things, even though they're already working in China, luckily in Europe, they will be forbidden. This is called social scoring, but also facial recognition or subliminal obscure manipulation, they will be forbidden. So what are the high-risk AI systems? According to the AI Act that is being put into place, so you should be concerned and highly regulating and highly attending to the requirements of this new regulation if you are doing any of these 8 cases. So you have from biometric identification of real people in real time and post-remote identification. Also the management of critical infrastructure. This includes traffic, water, gas, heating, electricity supply, energy. As you can see, this affects many fields. Point 3, education. So for instance, determining who accesses the university or making automatic exams. This form part of it. In employment, also AI systems that help recruiting or maybe process CVs or pre-screening, like you probably know the case of Amazon that was, they use an AI to, let's say, filter CVs, and it learned to automatically discard women because they didn't have many women in their team. So this needs to also attend to these requirements. Point 4, the access to public services and benefits. This includes, as you know, grants, services, many different public services we may apply for. Point 6, we have all the, let's say, applying the law, enforcing the law. So this affects human rights. So everything that will affect our human fundamental rights, it will be basically, as you can see, falling into one of these 8 cases. Also in border control, polygraphs, migration, right? And finally, the administration of justice and democratic processes. So what do this system will have to comply for? On the left, we have these cases summarized, and on the right, you know that you will have to establish a risk management system. You will provide some data governance procedures. You will have to provide also technical documentation, very extensive, also record keeping for any case that may be needed, transparency and information provision to users. Here it comes the explainability aspect, human oversight mechanisms, and accuracy, robustness, and cybersecurity. In this paper, we try to narrow down all these requirements, principles for trustworthy AI, and how to implement them. As you know, the context for this comes from the ethics guidelines for trustworthy AI, and you know that it's based on trustworthy AI, which means that AI should be lawful, ethical, and robust. And this is, of course, based in the fundamental rights principles, which is respecting human autonomy, preventing harm, fairness, and explainability, which is aligned, of course, with the UNESCO recommendations and responsible AI by design in practice, and many companies are putting into place these requirements. So if we look at the different axis, we have also a philosophical approach, apart from to the AI ethics. In the article, we narrow it down, and what we end up proposing is a definition based on these requirements for trustworthy AI, which you have here, which is human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination and fairness, societal and environmental well-being, and accountability. So the final definition we want to we come up with is that trustworthy AI contains responsible AI systems, but not only. Responsible AI systems also require testing some protocols and auditing technologies and some specification. And this will mean complying also with the domain-specific standards and ISOs being developed. So a responsible AI system will require ensuring auditability and accountability during its design, development, and use according to the applicable specification of the domain of practice. This means ex ante, before going to market, we will need auditability mechanisms for the vertical or sectorial regulatory constraints, as well as for the horizontal or AI-wide, like the AI Act regulation, as well as constraints imposed by the particular domain. This means also that after the product goes into market, we will need ex post some accountability requirements that will allow to demand responsibilities or liabilities. Then, in order to comply with these 7 requirements for trustworthy AI, I'm particularly focused on, I believe, 2 of very promising lines of work. One is continual learning. This is defined by Horizon Europe calls as ways of perform active learning, long-term learning, and how system can improve robustness and explainability. Here you have some works we have contributed to the field. And the second field is the explainable AI, which this survey that has become very popular. It's near 10,000 citations now. So I hope, I'm happy people find it useful. If you don't know about the topic, perhaps you can find it useful too. And one of the main contributions here is that we believe there was something missing on this definition of explainable AI, which draws insights from social sciences and the psychology of explanation. And we thus put the focus on placing the audience as key aspect to be considered when explaining a machine learning model. So we add this small nuance that and define explainable AI as giving an audience Unexplainable AI is one that produces details or reasons to make its functioning clear or easy to understand. And the audience is key here, because if they don't know technical details, maybe the explainability techniques are not useful for them. So you can see how different ways of explaining models can act. Local explanation, feature relevance, explanation by example, text explanation, model simplification, or visualization. Yes. And this is how they look to explain tabular models, or how explanation could look for explaining an image classifier that detects a dog or a cat with this kind of heat maps. This is how regular techniques perform. Or if we want to explain what makes this picture having an electric guitar or acoustic guitar, or explaining why a classifier between dogs and huskies may be biased and may take a shortcut and just look at the background, which is if the animal is behind snow or grass. This is what this technique reveals, that it's not really paying attention to what it should, right? So we have done some work to align explanations of humans with machines, with knowledge graphs, explainable neural symbolic learning approaches, and different position papers and overviews if you want to get into the field and find challenges ongoing that we keep working on. And I want to leave you here some references and a practical tutorial on how to use these techniques depending on your data type and audience. Thank you.
So thank you very much, Natalia, for this very clear talk, and thank you for explaining for us how much trustworthy and responsible AI is a complex topic, bringing and necessitating multidisciplinary skills to handle. We have a few minutes for questions in the audience, if you have. Yes, you have a question? No? And online, I don't know if there are, Maria, if there are questions online. If not, yes, Juan Antonio.
Yeah, so if there are no other questions, I have one. So you have mentioned auditability, and that's really a key aspect of knowing what AI systems will be able to do before running them for critical systems or others. How is this going to happen when you have systems that are opaque by construction? I mean, that's one of the main things that I would have as a doubt. I don't know if you have.
Yeah, this is the challenge. That's why we require some explainability, some transparency obligations. So the guidelines divide the transparency requirement into 3 elements. The first one is communication. We need to know when we are talking with an AI agent, chatbot, etc. Transparency, knowing what data is being used, how the model works, making us understand how it produces decisions. And the third one is traceability. So we need to know how data provenance, logging. In software engineering, it's some processes of lineage, software lineage. There are different aspects, of course. Black box model and LLMs are not really, we are not there, and we are trying to come up with mechanisms, and that's where explainable AI can help bring some interface that help us a bit elucidate causal relationships and some kind of explainability that help us debug it, understand them. Yes, so it's a challenge, but yeah.
Yeah, and there is another challenge is how to evaluate the result of the AI agent. I don't know if you know some work with, by yourself, you already work on the evaluation of the AI agent or the AI systems.
I think there are many evaluations out there in AI. I think what now we need to evaluate is the explainable AI, because it's also being shown that explanations are not always reliable. They can be manipulated to produce whatever we want to hear. So that's not, it's not the panacea, the explainability techniques. And sometimes, as you see the heat maps, you may have two similar ones and how you choose one or another. So they are pixel-based explanations that do not tell us the whole picture. So I think we need to work more on concept-based explanations that we can better align with our thinking, can be better automated and validated, that are less subjective. So we need to be evaluators of the evaluators somehow, and have human in the loop always.
Yes, is there a question? Okay, please go ahead.
George Karimiotakis, Min Paris. Thank you for the presentation. I have one question on the first part about regulation. If we take the case of a power system operator, for example, what does it imply to comply with regulation? What is the cost for this in terms of investment and real cost?
Yeah, indeed. I mean, for instance, in Spain, they are just drawing the adaptation of this European law, and they are kind of delegating to each agency or ministry or agency, for instance, energy agency or medicine agency for healthcare. You know, so each field is going to kind of reuse their expert knowledge, because we cannot have external people to come regulate a field they don't know. But still, this means that I forgot this. There can be 3 billion cost of bills of tickets if the high-risk AI system doesn't comply with the regulation, or maybe 3% of your annual revenue, something like that. The cipher changes. I can't recall exactly, but it's a big fine. So
okay. This means that if you implement a functionality like, for example, demand forecasting, and you have this cost, this means that your model needs to be much more performant than a conventional technique to compensate, so that you have benefits from the improvement of accuracy, so that you compensate the cost, actually. So we have two objectives. I mean, complying to the regulation means that we need the tools that have better performance than the state of the art, actually.
Indeed, this is a good point, because accuracy, robustness, precision is one of the associated to the requirement of robustness. But as long as I guess there will be some standards imposed by the industry. There is so much to be done yet. For domain-specific fields, it's not really well established, but as long as you comply with all the requirements, if you are transparent in your way of using and don't break the requirements, I think you should not have to pay this bill. So shouldn't be as a hindering effect. But of course, it requires investment in personnel and resources to comply with them.
Thank you.
Well,
so thank you very much. There are many things to discuss around this topic. We'll have opportunities to discuss with Natalia during the breaks and the lunchtime, so don't hesitate. Now we have to switch to the next talk. So I'm happy to welcome Mehwish from TélécomParis Institut Polytechnique de Paris. She will talk about her work on large language models and how to use symbolic AI to mitigate the hallucinations and to reduce the problems due to the huge size of the LLMs. So, Mehwish, the floor is yours.
Right. So thank you very much for the introduction. So I'm Mehwish and I'm Associate Professor in TélécomParis Institut Polytechnique of Paris. And my major area of research is, well, language model and symbolic AI currently. And it was previously deep learning and symbolic AI, so neurosymbolic AI in general. So these are the kinds of topics that I'm touching upon with my group currently, and you will see in the course of this talk a little bit more in detail. So I think most of you have already gotten in touch with language models quite a lot, like ChatGPT, right? So that's not the only model that is out there. So this is like a plethora of models which have been going on for a long time, and now they are coming out again, as you see here. So this is a little bit outdated, all of this, because every 2 months there is another version of something. So you may not see like DeepSeek or GPT-4o, things like this. But I found the best source for this to summarize whatever was there. Here, for example, the ones which are highlighted in yellow are the ones which are publicly available, meaning that the software is open source, so you have a little bit more flexibility to do whatever you want based on the tasks that you are dealing with. And the ones which are not are actually closed source. So as we were seeing something about the black box models like GPT, so the models from OpenAI. So the point is, yes, we have a lot of language models. They evolved from like word-to-vec neural language models to pre-trained language models like BERT to now what we see as generative models. And I happened to find one paper in 2010 saying the statistical language models as very large language models. So our perception of what is a large language model has also changed quite a lot over the past 15 years. So as fascinating as they are, of course, we also know that they are prone to errors and overgenerations, hallucinations, things like this. So these are many of the things that you find that large language models are actually suffering with. So whenever language models tell you something, there is always a citation gap because they are not able to usually cite the source of the information. This is one of the work that we are currently continuing in seeing if language models are actually citing their correct sources. Then we have the truthfulness. Of course, sometimes in the earlier models, it was a bit a lot, but as soon as you are going further, it is getting better and better. So you have more truthfulness now than before. However, it still creates some wrong answers. And in many times it has the problem of multilinguality also. So if you ask in one language, it answers you it in another language. You might have noticed that quite a lot. And even though it is sometimes erroneous, you have like quite fluent style and it has a very confident tone, which is getting a little bit lesser confident by time because many people has targeted these kind of things quite a lot that, yeah, you are giving a wrong answer very confidently. So now they are further fine-tuned based on the task you want to do or things like this. So you have a little bit more credibility to what they are saying. And then you have the problem of outdated knowledge, which is when the model is trained, it only contains this kind of the knowledge which is up until that particular time. So right now, if you ask something about the event which has happened in 2025, I did not add the example here, but I was trying that out yesterday. So it actually explicitly tells you that my last training was until 2024. So I do not have enough information about that. So it does not overgenerate anymore, but in the previous models, it used to just make up stories about these kind of things. It has lack of grounding, of course, and then we have many times the problems with the evaluation, for example. So, of course, it depends on the task that you are doing. For example, sentiment analysis, things like this. So you can do this kind of accuracy. But there are, and in any case, language models are pretty good with the common tasks, just such as sentiment analysis or these kind of tasks, because they have seen quite a lot of data on that. And these are very trivial tasks for it. But as soon as you go towards more difficult tasks, it becomes much more, it starts generating much more errors. So to do that, we are currently looking into some pipelines for fact checking. So we have, of course, this is also a source from other labs which are doing, and it is quite generic pipeline, which we are trying to now specify. So what happens is that you get the output of an LLM, and what we are trying to do is to check if the claim that is made within this within the output of the LLM is correct or not. There are now several ways to do that. So I'm just mentioning in the slide one of them, but I will tell you more. So for example, first is that you try to process the output and you retrieve the information from external sources. So one of them is, for example, Wikipedia, which has quite a lot of knowledge out there for mitigating or these kind of hallucinations if they happen, or to give grounding to the knowledge that language model produce. The other one is some web search tools like Google API, things like this. And third one that you see here is the knowledge graphs. So these are containing information, the encyclopedic information, or even biomedical knowledge. So it is like a huge cloud of graphs, which is keeping the information about several domains. And this can be used for actually retrieval augmented generation pipelines. And the next part of this pipeline is to do stance detection and textual entailment. And what actually it entails is that whatever the claim is generated by the LLM is actually supported by the external source, the evidence that you have retrieved. And then finally, you have the veracity detection. So I'm not sure if you're okay, veracity detection, which means if it is true or not. So these are like the pipeline in which you are actually using external resources to validate what is there. But what if there are no external resources that you could use? So in such cases, currently we are working on trying to verify the reasoning chains which are being generated by the language model. So you ask the language model to explain why it is saying what it is saying. And each time if you do that, our models have performed quite good, for example, in natural language inferencing tasks. So what we are currently looking into is to perform some kind of logical reasoning into these reasoning chains. For example, if you have a hypothesis and a premise and you are trying to find a conclusion, if it fits to whatever the hypothesis is there. So this is happening within what LLM is actually thinking. So not only that, while doing these kind of explanation, there are sometimes that you have wrong reasoning and correct answers. You have several kind of issues that you go through. And in many times, we have also observed that you have sort of a knowledge conflict within the language models. And why does that happen? Because it has been trained over the data from a lot of resources. So they can have conflicting resources, conflicting information. There could be also the blogs of the people who are saying different things. So you have these kind of knowledge conflicts which are there. So for example, in the first example, if you see, it is pretty static. It's like a factual question that you ask it. But in the second one, if you see, you need to know the temporality of the fact that you are looking for. So it's like, what is Rome the capital of? So in 2024, 2025, it's Italy, but before it was a Roman Empire. And then you have the disputability kind of questions, that which ethnic group is most commonly affected by lactose intolerance. Europeans, Asians, you can have different perspectives of the answers. And it is really disputable because you cannot really attach it to some ethnic group without having the true statistics behind. So you have these kind of knowledge conflicts which are being happening in these language models. And then these are happening because of the training. As I said before, that you have quite a lot of training data, which is coming from different sources. So you have these kind of conflicts. And then you have also the conflicts because of the context memory that you get, that can be like parametric knowledge, which is contradictory. So you have, if you try to test the accuracy of the language model on some static data, it always performs better. When you have disputable, it is still performing okay, but with the temporal information, it is still suffering. So you have Quen2, which is one of the recent ones. However, these models are still a bit outdated because the current one that is there is DeepSeek, which is actually fine-tuned on these reasoning chains. So this might actually perform a little bit different. And then where the symbolic AI can be actually useful here. So of course, we saw the side of the LLMs. So symbolic AI here in this case, for example, knowledge graphs, it can try to rewrite the queries and give explicit temporal information to any of the questions. For example, implicit question can be turned into explicit question. And there are pipelines with retrieval augmented generation for this. So knowledge graphs are much more easy to update. So these are graph information. You can add edges and the nodes there. So this way you can have access to updated temporal knowledge each time you want to do some queries. So here in this case, the retrieval augmented generation is actually quite useful with the help of the knowledge graphs. Okay, I'll try to go a bit fast here. So the final thing that I would like to talk about is gender bias in LLMs that we are currently looking at. There is one study that we are currently conducting, which is on the explainability of language models, but post hoc, of course, we have the black box models. And here we are also looking into the gender bias of how if the LLMs know the entities which are of male gender more than the female ones. So here is one of the studies which is ongoing is that you take, for example, some of the personalities which are prominent based on their gender and try to generate words from that. And then when you look at the generated words for the females, you have mostly the words which are based on family status, social characteristics, things like this. And then you have for the males, profession, attribute, achievement, or behavior, these kind of things that you see. So we are currently working with Yorcom on this for editing knowledge within LLMs with the help of working on the logic level of the language models for the open source models that we have. So finally, my message for all of this is that we can definitely use knowledge graphs for the explainability and making the LLMs a bit more reliable, hallucinate less. So these are the kind of things like fact checking based on these knowledge graph, the factual information within the knowledge graph. So this is like the ongoing field of investigation, which is helping quite a lot with the language models. And we are working on this with many partners. So thank you very much.
Thank you very much, Mehwish, for this great talk. So I'm asked to keep the time to let all the questions for the end of the session. And it makes sense because all our speakers may provide complementary answers and different points of view for the same questions. So now we'll switch to the talk of my colleague, Vicky, from the Computer Science Department of École Polytechnique. So she's our specialist in multimodal AI. So we stay in the content generation. So we will switch from text to text, video, and image generation. So Vicky, the floor is yours.
Thank you, Sonia, and thank you, everyone. So I promise I will be on time. It's 52. I will do 10 minutes. I want to spend like 10 valuable seconds thanking the organizers and everybody for being here. Maria, Juan Antonio, everybody. It's a pleasure to be here, and I hope you will enjoy the talk. So as it has been said, our part of today's session is mostly to discuss research and research advances and to stimulate this in you without discussing regulations, or at least from my part, I'm not that expert on regulations. However, I do work on multimodal generative AI, and I will present to you today some research perspective on that. So this is a great, oh, this is another laptop. Oh no, it's just, It's a slow. Okay, sorry. That's okay. That's okay. 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 Some things about me. I'm at Polytechnique for the last 4 years. I'm a professor there. Before that, I was in Oxford. Many moons ago, I was in Edinburgh. I was at in Grenoble, where I did my PhD. And it's a great transition to what was said before, because generally, everybody knows this type of architectures. You know it by the name ChatGPT. So you know that there is this thing called generative AI, and you know it via ChatGPT, which the T, and ChatGPT comes from. There are a bunch of other examples of transformer-based architectures like Llama or Claude and so on and so forth. However, all these architectures are great if you want to generate text. Yet, like some may argue that our world is multimodal. Therefore, what we would like to do is to have like more modalities being generated, for instance, images or videos or 3D data and so on. So how do we do that? The more advanced amongst you may say, I will just write on ChatGPT, generate an image of a pink elephant, and ChatGPT will do so. Yes, but what you do not know is that behind ChatGPT, there exists this other type of models that are called diffusion models that are the ones that are actually doing image, audios, continuous data, and so on and so forth. For example, within ChatGPT, there is this DALE, one that is being used to generate data, and Stable Diffusion, that is the open source version of that. There are a bunch of others that I don't do an exhaustive list here. It's just to tell you that there exist two big categories, two big families of generative architectures. They are blended nowadays, but I'm not gonna go into a lot of details on that. So today's talk is gonna focus on this second part. So how does this work? In a very, very, very abstract level. We start from an image, and we sequentially add noise to the image until we end up in a completely noisy image. We do that with something with mathematics, and then we are removing at every step noise of the image with mathematics. And the generation part is that we are learning a network that is learning how to remove noise at every step of, so some things are not rendered very nicely here, but it's fine. How to remove noise at every step. So how do you go from this image that is like this noisy dog to a bit less noisy dog, and so on. And by doing that iteratively, we learn this type of network. And we have results like this teddy bears mixing sparkling chemicals, or an astronaut riding a horse. And these very photorealistic things like Midjourney, that is the most well-known, perhaps paid version if you are running any startup that you want to have automatic images, probably you're using that. Or DALE 3, that is the one from OpenAI, the mother company of ChatGPT. Stable Diffusion 3, which is one of these open source models, one of the most famous ones. Respectively, here we have text to video. So this was supposed to play as videos, but it's a PDF, so it didn't render apparently. But oh well, there is a video and audio here somewhere behind. That we do not see. Same for here, that this was a 4D human playing, but in the PDF, it's not playing, but this is a 4D human that we are generating, which is metaverse, something like that. So the motivation behind this and behind generally my work is the following. First refers to controllable generation, that what we would like to do is to have precise control over what we would like to generate. The other thing refers to structural representations, which means that we would like to have explicit geometric and mathematical forms that are gonna tackle diversity. The other thing refers to cross-modal bridging, where we would like to have these natural transitions between modalities. For instance, generate a video with audio, with sound that the speaker is speaking at the same time as their lips moving. And another thing which I like a lot, it refers to visualizing plausible scenarios for the future. So let's see some specific challenges. One challenge refers to controllability, which I'm going to discuss today. So if we went to prompt ChatGPT, that was some months ago, it was 5 months ago, December 2024, trying to have a glass full of wine, we would have something like a glass full of wine, a glass full to the brim, it overflows, but ChatGPT is unable to generate a glass full of wine. Probably because ChatGPT is made by French people, or because we don't have so much controllability. So that's challenge one. Challenge two refers to efficiency. So here with this simple diagram, I saw that the more parameters the model, which means the bigger the model we have, the better the score. So we will have something along this line. So it means that we have bigger and bigger models, translates to more compute, more time to run, and so on and so forth, better performances.
So that's another big challenge when it comes to generative AI. And the third one refers to ambiguity, that ambiguity can happen in space or in time. For example, if we would like to localize this, we don't know exactly where it is, so we'd like to have this type of probabilistic heat maps, or in time. So this is, spoiler alert, is from the movie Prestige, that you need to go somewhere back and forward in time to understand this ambiguity, that there is a twin doing some magical, some magical tricks. So these are the three challenges that I'm gonna very briefly discuss today, and show some examples on how we can tackle. So I'll start with the first one, which is controllability. So with controllability, we'd like to have like multimodality, compositionality, editing, and so on. So let's see one example. Traditionally, we are generating something with this equation. It doesn't particularly matter what this equation is. It's just this term says generate something that looks realistic, and this thing says generate something that follows this label. This Y here is a label that says a pink elephant. And what we are saying is that with this, we don't have so much controllability, but we can really understand the generation process, make it a function of the generation process, and we can have like more controllability by changing some parameters. For example, two birds flying in the sky in the bad weather, we will have something like that with the traditional ChatGPT type of architecture. Whereas with our type of architecture, you will have like more photorealistic details, and you will see like the beaks of the birds and the wings and so on better. So this can also be significantly faster. Another type of controllability, I mean, this is a bit that doesn't play as videos. This is so this really refers to what we call optical features. So we cannot see here. So the first one is zoom in, that you would like to have like a video that is being generated. And let's say that we all pretend to be Tarantino or whoever your favorite director is, and you want to have these zoom in effects or this distortion or fisheye or focus on the character and blur the background if it's a romantic scene and so on. So all these type of optic characteristics are not really integrated right now in the standard like generation processes. So these are the type of things that we would like to do and to have like this dolly zoom things and like iconic effects from various like famous movies and so on. But it's unfortunate we cannot see here, but go to my website. These are pretty videos playing there. Another thing refers also to, again, like this visual generation, but in this visual generation would be how can we have something that is being generated with character awareness. So if we want to place the cameras in a room, how would these cameras be so that they focus on my pretty face while I'm giving the talk, and at the same time when somebody else is speaking, they will focus on this person and they will do this back and forth. So this is the camera movement over time that can go to a room, can go to any type of studio. So this is what we are trying to do here. I'm sorry, this did not play. This is very fortunate, but we had the camera anyway that is moving over time. Challenge 2, efficiency. Efficiency can be about training data, can be about model size, or can be at when we are really having something on our mobile and want to run it as fast as possible. So in our works, what we are saying is that the traditional way of having data sets is that we go online, we scrap the web, which means that we download a lot of images with a lot of metadata, that these metadata are noisy. So what we usually do is this filtering process that we say, is there a good association between the image and the metadata? If yes, we keep the pair. If no, we discard it. Instead, what we are trying to do is say, okay, like let's keep it and let's learn still like image level information and underlying structures with this type of architecture, which turns out to be like small and good and with several good details, and we have a lot of controllability over it. For example, if we look at the one on the bottom, an armchair in the shape of an avocado, then we will, like, the more we increase this type of coherence score, the more we want the text to be associated to the image, the more the image will look like what we are asking it to be, that gives us more controllability. And we have a lot of photorealistic details, like, I don't know, like this cosmic marble, pirate ship trapped in a cosmic maelstrom nebula. Like, this is really like, I don't know, like, it makes you dream or something like that. It's very high quality. And like what we see with the prevailing thing is that we still need to collect like billions of data. So this is the standard paradigm that we see here, that we have like long, like big data sets. The bigger the data set, the higher the performance. And instead what we are asking is, can we have a very high performance with few data? So here we have data set size. And in our case, we are using a data set that is called ImageNet, that is very standard. And we
we saw that by doing several text augmentations and image augmentations, we can actually do that. And the last thing refers to ambiguity that can be like in the distribution. So in our recent work, what we are doing is that we are saying, can we model, so you should have been able to see that, but can we understand where an image is taken on Earth? And we can see that we can model this as a probabilistic distribution. For example, here, by having this image here, we can see that this is like the model is able to predict that this is in France, as opposed to this pigeon that will give a probability distribution all around the world. And we can see that this works with faces. So this is my PhD student whose work this is, or also with my dog, that we can have things like somewhere in Paris, somewhere in Budapest, or it's a world traveler. This dog, his name is Ketchup. And then here, for example, is able to localize that this is like Mediterranean vibes, but not exactly where. So this concludes like the three challenges that I wanted to discuss. And when we are discussing the future, I think that one big future within generative AI will be around abstraction and around reasoning, how to reason more into the generation process by having various levels of abstractions. Thank you for your attention.
Thank you very much, Vicky. Now we'll switch from the technical aspect of AI and generative AI to the social impact of AI. So we'll have the pleasure to listen to my colleague Anne Alombert from Université Paris 8, and you're also a member of the Numerical and Digital Institute of the French government. So Anne will talk about how we can mitigate the spread of deep fake in a social network by working before on the recommendation system. So we are all ears for you.
Thank you very much for this introduction and for your invitation here. So yes, I'm not coming from computer science. I'm coming from another background, which is philosophy. And I worked with the French Digital Council on the question of the social and political impacts of digital technologies, and more precisely on social networks and generative AI. So in this brief talk, I would like to provide a brief overview of the challenges raised by algorithmic recommendation on commercial social networks and generative AI, and to suggest two levers to overcome these challenges. So the first one is on the side of regulation, and the second one is on the side of innovation. So I start with an overview of the challenges or problems which are linked with disinformation, of course. So my point of view is to consider digital technologies or digital platforms as media technologies or publication technologies. And the question of media technologies or publication technologies is a very important question in the democratic societies, because democratic societies or republican societies need a public space in which some public information or public symbols, public text, images will circulate. And if we look back from the 70 last years, we can see that our collective public space and our collective public technologies have evolved very quickly, because at the the century before us, we were living in a printed milieu in a way, with printed press, newspapers, books, and then from the middle of the 20th century, audiovisual and analogic technologies were developed. So the public sphere was completely transformed with radio, television, etc. And in the 90s, digital technologies developed, and it was another big transformation of our public space through digital technology. So the first big transformation with internet, the websites, the blogs, the forums, was the fact that some citizens could publish informations. I mean that before, with radio or televisions, citizens were more in the position of the receivers of information, okay? There were people who were publishing informations, contents, and other people who were receiving this content. And then with websites, internet, citizens became able to publish some content, also some videos on the videos platforms. But with the advent of social media, what we call social media, so digital networks and commercial platforms, something so in the 2010s, something important happened because these social networks and these social platforms are based on algorithmic recommendation, which means that the company who owns the network or the platform is developing the algorithm which is recommending the content. So this means that everybody can publish some content, but then some contents are visible and some other contents are invisible because of the recommendation algorithm. And of course, these contents are very personalized, and each person receives the content which is supposed to be appropriate to her taste, but all this is controlled by the owners of the platform. And this is a problem because these platforms are not assuming the role of media. They are pretending to be neutral, but in fact, they are not neutral because through these recommendation algorithms, they are imposing a kind of editorial line. So, and also these recommendation algorithms are very vulnerable to fake accounts, fake profiles, which can be used by industries of disinformation in order to manipulate the recommendation algorithm. For example, you can buy some fake accounts, fake profiles in order to click a lot on a video, which will be amplified by the recommendation algorithm. And this is the main cause of the diffusion of disinformation. So, and of course, with generative AI, this will be worse because it is very easy with generative AI to produce fake news, which seem very authentic. And it is also quite easy to feed fake profiles or fake accounts with fake content. So this phenomenon of massive diffusion of disinformation may get worse. So the point I want to make is that if we want to change this state of fact, of course, we have to act on the question of recommendation algorithm. And the Digital Services Act is already offering to act on this because it is imposing these social networks and social platforms, social media, to make this algorithm transparent. So they will be forced to shed light on the criteria of this recommendation algorithm. But we could go a bit further. For example, and this is what we wanted to promote with the French Digital Council, if we force the platform to open their recommendation system to other stakeholders. For example, this means that if you get connected to a social network like Facebook, TikTok, or X, or any social network, you would be able to choose your recommendation algorithm as a user. You will be able to decide who is recommending contents to you. And the company will not be the only one to recommend content. And this could implement a kind of algorithmic pluralism. So you know that the pluralism of media is something very important for democracies. It is in France, the Conseil d'État is defining pluralism of media as one of the bases of our democratic regime. So the idea is to implement this pluralism in the digital sphere too, not only in the press or in the audiovisual media, but in the digital sphere too. And for this, we have to impose to the platforms to open their recommendation system, which is called the Unboundling or the grouping of digital network, and which is a legislative measure which could be discussed at the European level, I think, in the continuity of the Digital Service Act. And then such a regulation would also open the field of innovation in the domain of the recommendation system. Because I'm working with an association, which is a Swiss association, which is called Tournesol, which is developing a very interesting recommendation algorithm, which is based on the votes of citizens. So this means that some citizens are evaluating the content before the content is being recommended. So this means that citizens are voting for this or that videos according to public criteria, for example, the reliability of the content, the importance of the content, the relevance of the content, or the fact that the one who is publishing the content is someone on who we can rely, or things like that. And all these criteria are public, and every citizen can vote for this or that content. And then the algorithm is based on these human judgments, on these human evaluations, in order to recommend the content. So if you're interested, you can check on the platform online, which is called Tournesol. And it is, in fact, a really interesting innovation, because it's managed to articulate some computational technologies with some collaborative evaluation, so articulate some computational technologies with human judgments and interpretation and deliberation. And yes, so what I maybe want to say to conclude is that if we really want to limit the diffusion of fake news and disinformation, we really have to act upstream on the question of recommendation algorithm. And to act on this algorithm, I think two things are very important. First, to diversify the recommendation algorithm on the main commercial social network, and to enable new stakeholders to recommend the content. Wow. Ah non, je peux pas. That's okay now? Okay, fine. But I had finished anyway, so yes, I hope it was clear enough, and maybe if you have questions, we can continue during the discussion. Thank you very much for your attention.
Oh, it's okay. Oh, thank you very much, Anne, for this great talk. And now we will have the pleasure to conclude this session dedicated to AI impact by the talk of Maria from the Fusion Institute in Spain. So you will talk about how AI can be used for energy and for nuclear fusion. So the floor is yours. And we are all ears to hear you.
Thank you very much. So I'm María Ortiz de Zúñiga. I work at Fusion for Energy, which is the agency of the European Commission for Fusion in Europe. We're based in Barcelona, but my colleague Juan will tell you a little bit more about fusion in session 4 today. He is in Cadarache in France, where one of our biggest contributions to fusion, ITER, is what it's called, is being assembled. So I will be talking to you today about something that's a little bit different. So we've heard about language-based generative AI, trustworthy AI, explainable AI, content generation, social networks, right? As I was saying, our main focus at Fusion for Energy is ITER, which is the largest international collaboration on our planet. ITER also means the way in Latin, and it's no coincidence, of course. And later on, Juan will tell you about how we are trying to simulate the process that takes place in the sun and the stars to generate plasma, different state of matter from what we learned at school possibly, and get limitless energy. So building a machine of the dimensions of ITER and all the very high number of components, many of them are first of a kind, many of them are nuclear, generates a huge amount of data. Now, the nuclear field is not something that typically has a very big risk appetite, you could say, because of the implications it has. And that is possibly one of the reasons why AI has taken a little bit longer to be adopted by this industry compared to other industries, right? But it's also true that due to the large amount of data and to the complexity of the problem that we're trying to solve, we have to count on AI to operate, to simulate, to predict, and to control the plasma inside these machines, taking on from the positive experience of the latest fusion experiment. So you might have heard back in December 23, there was a big one that even made the Times magazine front page from the Lawrence Livermore National Lab. Recently, there was one from East in Asia. There was another one in France, which is the West Machine. So all these, slowly but surely, you could say, all these fusion experiments are making the news headlines. And this is in part also possible thanks to AI, which we can say is a positively disruptive technology in fusion science and engineering. So all in all, the outstanding ability of AI, and more specifically of machine learning, to analyze very large data sets and expose the correlations between complex interrelated properties results in AI and machine learning specifically having received quite a bit of attention in the field of engineering, all fields of engineering that are contributing to fusion. So machine learning as a branch of AI, which allows computers to learn and act like humans without being explicitly programmed, that's the beauty of it, and we'll see why it is so important in fusion, is used to discover hidden patterns in very complex multi-dimensional systems. So as you can imagine, data is key for AI, and the scale and the speed of data acquisition, accuracy, as it was said in the first talk, and volatility are our current challenges today. So using, structuring, and analyzing the data in a useful and process supporting way, known as feature engineering, for those of you who are more familiar with AI, is challenging, and especially in fusion engineering, where data is very wide in scope, because fusion in itself is very wide in scope, and sometimes shallow in depth. What does this mean? We don't always have a lot of data for a specific development that we would like to make. But it is important to retrofeed the data and the associated information with that data in order to make sure to fulfill that last step of quality control. So basically the last step is you have a lot of data, you have a lot of information. Are you feeding it back into your processes, manufacturing, design, operation, assembly, all of that? Or are you just keeping it in a wonderful document management system as a nice PDF that nobody looks at, right? So in engineering, we can simply use AI on data, or we can combine physics, understanding, and formulae with AI. Even combine numerical modeling technologies like finite element analysis or others, widely used in engineering design over the past 20, 30 years with AI, or even maybe longer, and time just goes faster than I can count. So AI either fills the gap where no formula exists, like you'll see in one of the cases that I'll go on and explain to you today, or confirms our physical understanding of our world, which is also very important because there are some, let's say, physical explanations that are quite recent in science, right? or synthesizes data in areas for which we don't yet have experimental proof. So let's go on to materialize these ideas and share a clear picture of our AI adventure at Fusion for Energy. Let me share with you some use cases. So one of our biggest, or the biggest, nuclear class safety component is called the vacuum vessel. So the vacuum vessel is basically a double-walled donut-shaped container where the plasma reaction will take place. It's made out of a special austenitic steel called 316 LNIG. IG stands for ITER grade, so you can imagine nobody else uses this much. And it has a safety function as well as a structural support function for many components. So the way ITER is set up is that there's a procurement sharing among all the 7 different parties, and Juan will go into it possibly, but in this case, South Korea is manufacturing 4 sectors. These are like orange little sectors, right? And Europe is manufacturing 5. So out of the 9 sectors making all of this, Europe has 5. In our 5 sectors, each one has 1 kilometer of welding. This doesn't mean that you start and you weld for 1 kilometer. Each weld is roughly, on average, 400 millimeters. So just say half a meter long, okay? So you can imagine this makes up roughly to 10,000 welds on 60 millimeter plates, which is not either the conventional way of welding. You don't usually weld such high thicknesses. So where can we use AI here? So one and the first case where we started developing an AI model was to predict the welding success. Why? Because when you have such a high number of welds, and most of them in parallel, you want to make sure that the next one you weld will be correct, so that you don't propagate mistakes down your line very fast, because you're trying to go at full speed and deliver these sectors as fast as possible. And especially when you're going into an advanced welding technique like we were doing in this case, which is electron beam welding. So this is done in a vacuum chamber, and it results in a very controlled and precise weld. But obviously, any small alteration in these parameters can result in a defect. So at a certain point, out of 2.5 kilometers, 17 meters of welds, EB welds, failed. So this is only 0.70% of the welds. So in theory, according to nuclear standards, we were fine, but still it's 17 meters that once you inspect, you need to find out where the weld defect is, repair, rescan. It's a huge disruption, plus all the associated documentation that goes with the high traceabilities that is required in the nuclear industry. So we thought, okay, let's predict if the next weld is going to fail or not. Naturally, you go and use statistics, right? Well, statistically, we had a 50% chance of failing, which is the same as not knowing anything, because if you're going to fail 50% or not fail 50%, that we knew already without doing any calculations. So we went one step further and tried AI. And even though AI, you could say in its most basic form, is a very advanced math, basically, or very advanced statistics, the truth is that even the simplest AI, which is machine learning, gave us the prediction that we wanted. So we organized more or less 3-4 years of welding data. We had 1,800 electron beam welds performed by the same supplier in this case. And we used a very simple regression method from machine learning to predict the remaining welds. So we compromised accuracy and speed, so performance, because we're dealing with large data sets, and also conscious of the sustainability of AI and the AI impact on the carbon footprint. So at the end, the model predicted that one weld would fail at 96% probability, and it failed. 16 welds were supposed to be at 56% probability. Of those, 9 passed and 7 failed, so it was spot on again. 53 welds passed as predicted. So we gained that additional knowledge that we didn't have from just using statistical methods on our data. And something that we saw worked for this very specific and critical case. So this methodology has then been propagated to other components and other kinds of welds, and the accuracy keeps on being so high. So you can imagine everyone at F4E is now very eager to develop these models for welding prediction. So I have a double background, computer engineering and mechanical engineering, so I knew this was going to work. But you can imagine my colleagues who don't have such an understanding of AI were telling me, well, it's not going to work. This is like a black box, black magic kind of approach. It's not going to work, but you go on, you do your little games and let's see what happens. So when they saw that this worked, they're like, oh, let's go on to our next problem. I'm like, okay, what's your next problem? They like, phased array ultrasonic testing. And for those of you who don't know what this is, so when you go to the doctor, there's a scan that they do right on any part of your body, which is ultrasound. So it sends one beam down and you get one beam back up. Phased array means that at any spot, you get a number of beams that are like balayage kind of thing. So you get a few beams back. And at every, quickly, okay, I'll speed up. At every millimeter, you're sending out 29 beams, 400 millimeter weld, again, 3.7 something million data points. I'm like, oh, this is wonderful for AI. So according to the RCC-MRX nuclear code, it tells you need to find all the defects, planar and circular. We went on, developed not a machine learning, but this was neural network and deep learning. And we could identify all the weld defects with a 99% accuracy, and it would tell us exactly where it is. So something that took days now took a few minutes. So we don't replace the UT inspector because the nuclear code is not yet there, but we have additional information and we can decrease that inaccuracy of 3% that a human usually has. We've also used it in material engineering, but I won't go on to those details for the sake of time. So this work, as you can imagine, is being shared with the nuclear design co-designers and operators. Their first impression is very good. Some of them are willing to introduce it already in the upcoming editions. And I have to tell you, as someone who's been working this field for a few decades, it's impressive because usually you take at least 1 decade to qualify material, to qualify procedure and these things. So this is very, very impressive. And you can imagine a lot more work has been done on AI at Fusion for Energy. We're collaborating. We also recently started road mapping all the AI technologies that are needed for fusion science and engineering, so that we can also consolidate these developments in Europe and hopefully all benefit and accelerate fusion or the potential of fusion in our world. Thank you very much.
Thank you, Maria, and I would like to thank all of our speakers. You really highlight how the AI and its power can be used for good and can help our societies, help the industry and business in different levels to gain on performance, on productivity, on creativity, but in the same times it's bring many risks, risks to our democracy, risk on sustainability and climate. And also because these technologies are evolving very, very fast and spreading everywhere, but they lack on transparency and trustworthy. But we show also during this session that as researchers in computer science, applied math, and digital technologies, we are working on developing new technologies, AI technologies, which will be more trustworthy, transparent, secure, and we have tools to switch to a safe, transparent, and responsible AI. There is a lot to do. We are at the beginning of this revolution. So many questions are open. So now it's time to open question for the audience. So please, if you have questions to our speakers, don't hesitate. Yes.
So just for the sake of information,
We can take, I think, like 10 minutes questions. We are in the time of the break, so I suggest to take 10 minutes questions and then move to the coffee break and continue the discussion. Okay.
Hello again. I would like to ask a question about the generative AI. If we consider this pyramid at the beginning from the first presentation of the second level where we have critical infrastructures, what would you think is the TRL today of generative AI for applying this kind of tools based on generative AI in this kind of level of applications? For example, for power systems. Is the TRL high enough today to say that we can apply generative AI to power systems, which is a critical infrastructure?
It's for you, Natalia?
Yeah, it's for you. Yeah.
Yeah, because yeah.
No, it's okay. No, it's not about the level. The question is for you.
Okay, so okay, I see. Because you were referring to the triangle, which was actually in her.
Just
talk,
to place,
that's right, yeah.
just to place the criticality of the application.
Yeah. So these kind of researches that I was talking about, I think these are quite in initial stages, I would say. So they are not very much applied to the real world application yet. But we are trying to collaborate with industries to see what kind of real world collaborations there can be. So TRL is a bit lower in that sense.
Okay.
Yeah, so in any case, whenever this is like a very general thing that whenever you try to go from this theoretical benchmark data sets where you are testing your approaches, things like this, as soon as you move on to the real world challenges, it's the accuracy goes down. You have to involve human for evaluation, these kind of things. So from my side, I'm not very much aware of these kind of applications that you are talking about because I don't keep myself updated from this, but I think, yeah,
Okay.
I'm more on the
The reason I ask is because recently came out the Horizon Europe new program, new calls. Since we are here at the headquarters of the European Commission, it's interesting. And there is a topic about a demonstration project on generative AI for power systems with a target of TRL 7 to 8. So I wonder, is this a good thing? I would expect more that the expectation of the European Commission is to develop research to solve all these aspects rather than use the tools that exist and go to the demonstration at this point, no?
Yeah, it looks a little bit higher, to be honest, if I think about it. Okay. Yes. But yeah, I think it's a good initiative to use these kind of things. But as we know that generative AI, we have quite a lot of instability, even though we have quite good models now. So yeah.
All right, thank you.
Yeah, maybe by combining not only generative AI, but with reinforcement learning, symbolic AI optimization, we can strengthen and mitigate the risk of generative AI. Maybe there are interesting things by combining multidisciplinary computer science topics. It can work.
Yeah, just to add to that, we are actually trying to do it with biomedical domain right now. So we will see what happens, but it does not for now look very good. But yeah, we will have soon some results there, so we will know. Yeah.
After the blackout in Spain, we should think twice.
Yeah. And it's clear that we have to fund more research and create more collaboration between industry and researchers to avoid this kind of disconnections. I think it would be good.
Hi.
Are there? Yeah, please.
Well, I will introduce myself. I'm Magdalena Salazar. I'm from the Universidad Carlos III de Madrid in Spain. And also I am the IEEE European Public Policy Committee Chair. So my question is more related to the last speaker, because I understand that talking about the blackout that we have in Spain recently, I see in the topic that she's working, fusion, as one of the big solutions for getting more energy. In the second stage of that research, going from the stage, the current stage, to producing energy. So I know that they have been funding from the European Commission for all these projects, but how far are we in regulations by the European Union in that topic? Are there any policies already designed or projects on that?
So initially, when ITER started, it was decided not to not to create parallel codes for fusion, but to use the fission codes, right? And this is the decision that was taken you could say, ITER is based in France, so it was in France. You do see now in the later, very recent years, 1-2 years, that the UK is taking another approach, right? And the US is also taking an even more different approach. What has been happening since the beginning of ITER is that we have some codes that are specific to experimental machines like the RCC MRX, where, as you can imagine, we actively contribute, but not only us, there's also the sodium fast reactor, there's a number of projects that are in France. I cannot tell you how it's going to be once we need a commercial fusion machine, because right now we're in an experimental phase. After the experimental phase, you will need a prototyping phase, and then you will need a commercial fusion machine. So I can intuitively foresee that all of this will change, maybe even drastically, by the time we need a commercial fusion machine. Because as you know, the radioactivity in a fusion machine is very different, and the design of a fusion machine will likely be very different from the design of a fission machine. So I think taking all of this into account, taking the learned experience from ITER, we might see that things change over time.
Thank you very much. Well, my interest is also because my background is in electromagnetics. I'm a telecommunication engineer. That's how we call it in Spain. But my main background is electromagnetics and high frequency propagation and devices. Thank you very much.
Okay, hopefully you can come in the next edition of this conference to present the result of industrial fusion machines. Hopefully, we are waiting for that. Thank you. Are there questions? Yeah, okay. Please.
Good morning. I am Francisco from Matteucci from Fondazione Bruno Kessler. One question about the EU AI ecosystem that the Commission is growing up, and also on the light of the regulations. You have been speaking a lot about trustworthy, reliability. Do you think that the regulatory sandboxes that are this, let me say, I would call them low tools, where you can try to stimulate the discussion on the setting up or the modification on regulation about AI? Do you think that this type of tools could facilitate the ethics of AI, the use of trustworthy AI, or you think that there is still to be done other, let me say, regulations, innovations on this side to make it happen?
Hi, yes, definitely. Regulatory sandboxes are part of the game, and I think it's probably they're not the only one, but it's a way to have a safe environment as a test bed before they go to market. And the aim is precisely that, to align more with the ethical guidelines for trustworthy AI, and specifically with the AI Act regulation. So indeed, Spain is piloting this approach, and hopefully we get some results, and it's going slow. But out of it, I contributed also to write the guidelines to help small companies that maybe don't have so large resources to help comply with this. But it's going to be a long road, and we need all to contribute. But that's the point. I think that's the aim. Yeah.
Thank you. And Mehwish, also affiliated with IEEE European Public Policy Committee. One comment, one question. First is about the term. You all use the term AI. So would it be better just to say if you're talking about just neural networks or machine learning, or you're talking about a specific product or platform, or you're talking about a specific algorithm? That's easier for me to follow. And then now the question is, all of you are talking about the potential applications. We all know with computer science background, we all know everything could be processed faster, accuracy could be higher, but I haven't heard anything about the validation. Could any speaker comment on this? How have you done the validation study?
Thank you. So I'll start with the second part because that's more, at least clearly defined in my opinion. Typically, validations at academic environments are a bit different than real-world environments. It means that for any given set, there is something that is considered as data that we, like algorithms, can see and can learn from. And then we are withdrawing some data and we are using them as test set, which is the validation set respectively, that in theory, algorithms do not have seen, and we hope to generalize. So this has been the traditional like learning from data paradigm that most approaches here follow. Then there is the second, like a bit more into today's generalizable aspects, which is we train on a set that may have like many things, for example, like ChatGPT that has a lot of things from the web, and then we are applying to several domains, and we are expecting to see generalization. An example for this to make it more concrete will be, we train on data from the web, and then we expect ChatGPT or whatever the model is to generalize on Excel spreadsheets or on medical data. So as you can imagine, like some things that is about like completion of the New Yorker, then it may perform much better compared to some others that's around medical data or autonomous driving or depending on different domains. So this is the way to examine generalization is to try to have a validation or test set that are either within domain. Within domain means that we train on medical data, we test on medical data, we train on fusion data, we test on fusion data and so on, or to check cross-domain things, which is train on something and make it very, very generic, like ChatGPT, and we hope to apply on several domains. That's if that, and one of the basic principles on learning from data that is like much bigger than generative AI and so on is like that there is no leakage, means that we do not learn based on one particular sample, and we do not test on that sample and say, yeah, okay, we will learn that particular one. But we are trying to see how algorithms generalize beyond what they have been seen exactly. To answer your first question, what is AI? So that's perhaps also philosophical. So maybe that's like, but from the practical computer science perspective, it can be seen as we are trying to discover underlying representations of data and to learn from these underlying representations and to be able to express them somehow. One way of learning traditionally has been supervised learning. Another way of learning that is what ChatGPT is doing, self-supervised learning. A new era of learning right now is like RL, like learn by experience. But all these things is like you have data and you are trying to observe some commonalities around the data. The data can be symbolic, can be text, can be images, can be like touching a bottle from a robotic arm or whatever it is. But these are all based on the paradigm that there is some data and we're learning from that. So, but from the philosophical perspective, because it's not only CNNs, there can be several like domains. But from the philosophical perspective, somebody will give your answer.
I don't know if I can answer really. It's I think from a philosophical point of view, of course, it's a very problematic notion, artificial intelligence, because I mean, who knows what human intelligence is, you know? So it's all this kind of vocabulary is based on the kind of anthropomorphization of these technologies, and there are also some, you know, some strategic interest in using this kind of notions, because if you look at the really origin of these sciences, at the Dartmouth conference, for example, when the notion emerged, it was a kind of promotional notion in order to get some fundings to develop, the technologies those people wanted to develop. And Herbert Simon, who was one of the organizer of the Dartmouth workshop, already said we should not speak about artificial intelligence. We should speak about, so in French, traitement automatique de données. So I don't know in English how you translate data processing. Yes, and this is exactly what you just said. Like you have some data and you compute to find patterns. Or so yes, I guess now this idea of artificial intelligence it's also part of a kind of ideology in a way, saying that we are going to reach a point in which we will be able to imitate all human capacity and things like that, which is the idea of general artificial intelligence, yes. And all this for me is really a way to mask the scientific and the technological theory that are behind these technologies, and also the way that they are funded on human data, on human work, and also that they are accomplishing a process of automatization in a way, because what is automated now is yes, image recognition, it's the possibility to select among contents and all these things. So it's a kind of process of automation of our cognitive faculties. So yes, when I am using this kind of notion in a philosophical discourse, I try to deconstruct a bit this idea of artificial intelligence, of course, but then it has become a common term now, so.
Yeah, hello. Yeah, this is as a question for Anne regarding what you mentioned for the recommendation algorithms and have more plurality, let's say in your feed of your social network and so on. The concept I have is like, let's say social networks tend to maximize user experience. So they want to engage you to spend the most time on their app. So in some sense, they're feeding you already like this plurality, because for instance, I'm interested in, I don't know, in gastronomy, other people might be interested in art. It's already feeding me more of art or more than food or any topic you're interested compared to other topics. Also, I think you mentioned one way to mitigate or to enhance pluralism is like you can choose your recommendation algorithm, let's say. Will not this lead to echo chambers within the platform? And this is like, it will be a more severe problem than the one you are trying to solve?
Yeah, thank you very much for the question. This is a very important question, of course. The point I want to make here is that echo chambers already exist, but they are based, as you say, on your individual preferences, okay? So imagine you have different entities, for example, media or academic institutions or a group of citizens or companies who are proposing a recommendation algorithm. And they are telling you, these are the criteria of my recommendation algorithm, okay? So all this is transparent, and you are choosing which is your recommendation system. So it's a bit like when you are choosing what newspaper you are reading, you know, or what studies you are doing, or you see what I mean? Yeah. So yes, it is a kind of echo chamber in a way, but it is, I would say, a reflexive, transparent, and decided echo chamber. You know, we are all living in our own echo chambers in a way. Philosophers are not often speaking to computer scientists, and you see what I mean. But the point is that we know that we are in this kind of echo chamber, and we know that we can go from one to another. For example, I can go to a conference of computer scientists, and I could change my recommendation system. You see what I mean? For example, I could have a recommendation system from one political party and then change to another one, you see? And this I could do deliberately, because the problem that we have today with disinformation is that these recommendation systems are not visible for us. So many people are using, and especially young generations, are on TikTok, for example, and they think that what they see is the real world and the real information, and they do not even think that there is an algorithm behind. You see what I mean? I mean, some people know now because it has become a kind of problem, a social problem, you know. So, but visibility is really important, because here there is an asymmetry between the one who are deciding this recommendation and the one who do not see that someone is deciding for them. You see what I mean? So for me, echo chambers, I agree with you, it's a big problem, but for me, it's not the main problem, because echo chambers have always existed, you know, but they were not decided by three big tech companies, and they were like more diverse and more depending on people's will and decision, you see.
Thanks for the clarification.
So,
I think now I get it better, the idea.
Thank you. Unfortunately, the time is over, but there are still many things to do and to say and to discuss between us, but there will be the break, the coffee break and the lunchtime to continue discussing on these topics. So AI is bringing bridge. So it will be the word of the end. Thank you for all of you for attending, and to be so many in this room and online to attend this session. And I really would like to thank and to support our great speakers for your result, for your crucial work. And so thank you very much.